Let's work on one of these typical questions in the homework assignment. Question 71, using the newer versions of the scientific calculator, Casio fx-260. So what I have is a piece of paper, pencil, and a calculator. The question here is a typical tap weak acid titrated with a strong base question. We have 20 milliliters of 0.105 molar acetic acid, which is the weak acid, with 0.125 sodium hydroxide, which is one of the strong base. Both of them only have one hydronium and one hydroxide, so they are monoproteinic acid and base. To do this question, you need to know what Ka of this weak acid is. Let's see, number 71. The Ka for this weak acid, let's just simply say Ha. You can find it from the table, or it's given 1.8 times 10 to the negative fifth power. Now, the question's first step is to work to find out the initial pH. To find out the initial pH, this become a question of a weak acid with certain concentration. We need to write the weak acid equilibria. Water plus Ha, aqueous, you got hydronium, and you have the conjugate base. The initial change equilibrium will be given as, well, 0.105 molar, say 0, 0 at beginning. The change would be x, x, and negative x. Then at equilibria, you simply add the initial and the change. So 0.105 minus x, so that would be x, x. So once you have all this equilibrium concentration expressed algebraically, you need the Ka expression. Ka equals x squared over 0.105 minus x. Then at this step, you need to make assumption x is small. So x is small. How small is small? Which means essentially compare with, let's say, this 0.105. Remember, when you make the x small as an assumption, this x small is only use them in addition or subtraction. Then you can simplify this to Ka equals x squared divided by 105. Then do an algebraic expression. X squared equals Ka multiplied by 0.105. So multiple by 0.105. Then if you want to find out what x is, take the square root. Then here, let's use our scientific calculator. This is a scientific calculator. What you need to do is push the on button or clear everything. Let's say do a push 1.8 followed by this exp. Now you can see the power come out. You first push the 5 button, then see this plus minus button, push here to give you 1.8 times 10 to the negative fifth power. Now use this value multiple by 0.105. Then here you need to push enter button. So far you get the one inside the square root. If you want to find out the square root, you need to use the square root button, which is the same as the squared button, but it's written on top as a yellow font, smaller. What you need to do is you first push Shift, then push this x squared, which means you're going to use the function or operation on top. You got 1.37 something 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 multiplied by 10 to the negative third power. So here, since the Ka, we only have two significant numbers, let's keep two significant numbers in the answer, which turned out to be 1.4 times 10 to the negative third power. So that would be the equilibrium concentration of hydronium. Now the next step is to find out the pH, the initial pH. The pH equals negative logarithm of x. Since this value is still here, you can simply push the logarithm button right there. Now you get negative 2.86. So you can simply omit the negative sign to write this equals 2.86. Or if you want to change them to the positive number, say this plus minus button, push this, it will remove the negative sign.